Hilbert's infinite hotel paradox is a thought experiment which demonstrates that when we enter the realm of actual infinity, we must check our intuitions at the door. In this video, we'll start with the original paradox, and then we'll jump into the sequel. The Grand Hotel has a countably infinite number of rooms, all of which are occupied. But it has a clever hotel manager who has found a way to accommodate new guests simply by moving the current guests to different rooms. For example, he can accommodate one new guest by moving each guest one room up. In other words, guest N moves to room N plus 1. This approach can be used for any finite number of new guests. He can also accommodate a bus filled with a countably infinite number of passengers by moving the current guests to the even-numbered rooms. Guest N moves to room 2N, freeing up all the odd-numbered rooms, and passenger N is moved to room 2N minus 1. He can also accommodate a countably infinite number of buses, each filled with a countably infinite number of passengers. To see how, let's group the rooms whose numbers are the powers of 2, the powers of 3, the powers of 5, the powers of 7, and so on, going through the powers of countably infinite prime numbers. As for all the other rooms, we'll group them in the first column. He then moves guest N to room 2 to the power of N. For bus 1, passenger N is moved to room 3 to the power of N. For bus 2, passenger N is moved to room 5 to the power of N, and so on, accommodating every passenger on every bus with countably infinite rooms to spare. When it comes to the Grand Hotel, no vacancy and new guests welcome are not mutually exclusive. The sequel to the infinite hotel paradox begins in the Growing Hotel, a much more modest hotel with a finite number of rooms. But they aspire to compete with the Grand Hotel, and so they are continually adding rooms. So while the Grand Hotel has an actually infinite number of rooms, the Growing Hotel has potentially infinite rooms. The number of rooms in this hotel is approaching infinity, but it never gets there. At any moment in time, the hotel has a finite number of rooms, but we cannot permanently label any room as the last room because the hotel has the unbounded potential to grow. Now, given the ongoing construction, the hotel manager tries to keep the guests in the lower numbered rooms. And to be fair, he always starts each new guest in room 1 and makes room by shifting guests up one room. One peculiarity about this hotel manager is that he is a numbers enthusiast. So when he wants people to move rooms, all he does is announce a number on the PA system, and everyone is expected to know exactly what to do. Here's how his system works. He keeps track of the occupancy state of the entire hotel using a single number. Each fractional digit corresponds to a different room. A 9 digit indicates that that room is occupied. A 0 digit indicates that that room is vacant. So if he wants to update the occupancy state of the hotel by putting a new guest in room 1, he adds 0.9 to the current occupancy number. To keep things simple, he limits his announcements to the following two types of operations. 1 corresponding to vacating a room, and 2 corresponding to shifting a block of guests up one room. So for example, in this case, if he wants to vacate room 2, he would need to subtract 0.09 from the current occupancy number, so he announces 0.09 on the PA system. In this case, if he wants to shift the guest in room 1, he would need to subtract 0.81 from the occupancy number, so he announces 0.81 on the PA system. In this case, if he wants to shift the guests in room 1 and 2, he would announce 0.891. In this case, if he wants to shift the guests in room 1, 2, and 3, he would announce 0.8991. And in general, shifting the guests in rooms 1 to n is accomplished by subtracting 0.8 followed by n-1 nines followed by a 1. Remember that 1. Now, this simple number system works perfectly for him in the Growing Hotel. It works for 10 rooms, 100 rooms, 1,000,000 rooms. Let the number of rooms approach infinity, and it will work perfectly in every case. But one day, his dream comes true, and he becomes the hotel manager of the Grand Hotel. And since his number system works so well for him at the Growing Hotel, which has potentially infinite rooms, he decides to use it at the Grand Hotel, which has an actually infinite number of rooms. The first new guest enters, and as usual, he wants everyone to shift up one room. So without thinking it through, he announces 0.89999999 repeated. That little one that should come at the end never comes, because there is no end. And because of that vanishingly small difference, he's effectively saying 0.9. And so the guest from room 1 vacates his room. The hotel accommodates the new guest, but by undesirably dislodging a current guest. The hotel manager assumed that since his number system worked perfectly as the number of rooms approaches infinity, that it would work at infinity. But that is a leap of thought which he was not justified to make. This sequel is not about set theory, it's about calculus. The infinities in calculus are all potential infinities. We use limits to approach a value. The derivative is the slope of that line as h approaches 0. And that works perfectly. But we wanted to describe the case for when we reach the limit, when h equals 0. We want the derivative to correspond to the slope at a point, and that requires a leap from potential infinity to actual infinity. Are we justified to make it? Let me know your thoughts in the comments, and thanks for watching.